In this presentation, I'm going to talk about how to construct confidence interval for population mean when sigma is known. First, we're going to get the sample mean, the sample size, and the population standard deviation sigma. Then we find the critical value z alpha over 2 for the desired confidence level. Apply these values to the formula for the margin of error, which is z alpha over 2 times sigma divided by the square root of n. The general format for the confidence interval for the population mean is x bar minus the margin of error and x bar plus the margin of error. And then we go ahead and simplify the last answer. In this example, we're given the sample mean 78, the sample size 40, and the population standard deviation of 12. We want to find the critical value for constructing 98% confidence interval for the population mean. Then we're going to find the margin of error, and after that we're going to construct 98% confidence interval for population mean. So for the critical value, we're going to draw our standard normal probability distribution, which has a mean of 0 and a standard deviation 1. The 98% desired confidence interval will be the middle area, and that leaves us with 0.01 area for each tail on either side. Using the inverse norm from TI command and the left area of 0.99 with a mean of 0 and a standard deviation 1, our critical value is 2.326. Now we're going to compute the margin of error. We have the value for z, the value for sigma, and the sample size n. Plug those in, simplify. So the margin of error here is 4.4. Now we're ready to construct 98% confidence interval for the population mean. Plug in the values and simplify. So the 98% confidence interval for the population mean would be between 73.6 to 82.4. A reporter randomly selected 45 nurses and computed their mean monthly salaries. The mean was $6,975. The reporter also discovered that the standard deviation of salaries of all nurses was $525. We want to find the critical value for constructing a confidence interval for the mean salary of all nurses. Then we want to compute the margin of error for constructing the confidence interval for the mean salary of all nurses. We're going to round this margin of error to the nearest dollar, and then we're going to find the confidence interval for the mean salary of all nurses. So in this example, we're given the sample size n to be 45, the sample mean x bar to be 6,975, and a standard deviation for the salary of all nurses, sigma, is 525. For the critical value, we're not given the confidence level, therefore we use 95%. That's the default confidence level if it's not given in the problem. So 95% area in the middle, that leaves us with 0.025 area for each tail. Again, using TI command inverse norm with the left area of 0.975 with a mean of 0, standard deviation 1, the critical value will be 1.960. Now for the margin of error, we're going to apply those values to the formula for the margin of error. And once we have an answer, we're going to round it to the nearest dollar. In this case, the margin of error is 153. Now for the actual confidence interval, we're going to use the value of x bar and the margin of error. On the left side, x bar minus e, and on the right side, x bar plus e. Simplify these answers, and we get the mean, which represents the mean salary of all nurses, to be between $6,822 and $7,128. Now, finding x bar and margin of error from confidence interval. So if the confidence interval is given to us, the sample mean would be upper value plus the lower value divided by 2, and the margin of error is upper value minus the lower value divided by 2. In this example, we're given the confidence interval for the population mean. We want to find the sample mean, and we want to find the margin of error. For the sample mean, we take the upper plus the lower divided by 2. So x bar, the sample mean in this case, is 127. And for the margin of error, we go upper minus lower divided by 2. And the margin of error is 11.25. Now let's see how we can do this problem with using TI. Now the steps on constructing confidence interval on TI is very straightforward. We press Stat, we go to Tests, but since sigma is known, we pick the option for Z interval. On the input, it's recommended to keep it at stats. Then we enter the value for sigma, for x bar, for n, and for the confidence level, also in the calculator C level, and then we calculate. And the answer appears on the top. Now x bar is the sample mean, n is the sample size, sigma is the population standard deviation, And when confidence level is not given, the default is 95%. A sample of 36 exam scores in a math class is given below. We want to find the mean and a standard deviation of these exams and round them to a whole number. We want to construct 90% confidence interval for the mean of all exams. But we're going to assume that the standard deviation of all the scores is the same as the standard deviation of this sample. And then we're going to find a margin of error. And we're going to do all of that by using TI. So to find the mean and a standard deviation for these exams, we're going to store this data in a list, and then we do a stat, go to calculate, and then one variable stats, and we get x bar to be 72, s standard deviation for the sample to be 14, and n is equal to 36. Now to construct 90% confidence interval for the mean of all exams, assuming standard deviation of all is the same as the standard deviation of the sample, we're going to go to stat, we're going to go to tests, and then we're going to go to z interval. We enter the values for x bar, sigma, n, and c level, making sure the input is on stats option, rounding it to one decimal, we get mu to be between 68.2 and 75.8. For the margin of error, we're going to go upper value minus the lower value divided by 2. So in this example, the margin of error was 3.8. As a reminder, when constructing confidence interval for the mean, if the confidence level is not given, we use 95%. If the significance level is not given, we use 0.05. Significance level should be divided by 2 to find the area for each tail. And we always make sure to verify that the standard deviation given is belong to sample or does it belong to population. I hope this presentation helped you understand how to build confidence interval for one population mean, assuming we know population standard deviation sigma.